All right. Let's do this. Welcome to Space News. Hello, everybody. I am EJ, the one and only host of Space News. How's everybody going? It is Wednesday, December 11th. And, yeah, we should be good to go. I have a couple of different things to show you here for today's Space News. Yeah. So, once again, the power might go out. It is extraordinarily windy here in Massachusetts up today. So, yeah, the power... What the hell? No, I don't want audio there. Jesus. This thing. I swear. Okay, where did that link go? Okay. Yeah, it is raining like crazy. If the stream suddenly does go out, you know what happened. Still haven't gotten the whole home generator. No. Okay, give me one moment. Okay, so New Glenn SLS. Let me put on Starbase Live background noise so the headset won't go out. If that's what we want, we could share that first. So, if you watched Space News yesterday, we talked about different architectures that you could use to
Discovery, go at throttle.
Different architectures that you could use to mess with what's the right way to say this? To fix SLS, right? So I had Snackless in Twitch chat over there. He decided he wanted to put some little bit of graphics together. So Snackless, thank you for this. This is what I'm talking about. And you know what? I'm looking at this and there's a big Snackless. Yeah. There's a big, I noticed a problem with this. It might be too tall for the VAB. You might have to extend the VAB, but hey, whatever. It doesn't matter. Anyway, that's what I'm talking about. Orion on New Glenn, right? And then New Glenn Upper Stage and payload fairing on SLS. See what we're talking about here? See what I mean? Yeah. Yeah. That's what I'm talking about. Hey, Steve Marie, what's up? How's that, huh? Around about 34-month resub. Thank you very much. Yeah, of course, now that didn't work. The VAB is modular. You might have to do some modifications to it, but I'm pretty sure making a building a little bit taller is less expensive at this point and a easier solution than trying to build a custom outfitted upper stage for SLS like what we're trying to do right now. How long to human rate New Glenn? I'm pretty sure it's human. It can tick all the boxes for human rating certification. Korean. I'm pretty sure Blue Origin built it to be human rated out of the box. It's not. It hasn't gotten the rating because they haven't done it yet. They haven't applied for it. So, would this allow a 10-meter fairing? The other thing that you could do, Nova, is do a load reactor, and basically have a 10-meter. Have it or an 8.4 meter fairing all the way up to here and then out to a 10 meter fairing there. That could work. That could work. But yeah, how's that, dude? I must say, SLS with a New Glenn upper stage and a 7-meter fairing on top is quite the looker. That's quite the looker. That's As I said, 5 years for human rating New Glenn per Tim Dodd. Yeah, if you get some flight data behind its Psycho, yeah, he's, yeah, I mean, Jeff's right, obviously. He runs an aerospace company. Yeah, 5 years would be about right. I mean, someone send this to Rook. Yep. The only thing that I'd be very, very concerned about is, once again, the VAB. You would have to extend 2 high bays. So, High Bay 1 and High Bay 1 and High Bay 2 would need to be extended if, you know, playing off the notion that High Bay 1 would be reconfigured for SLS Block 1B. That's what you'd need to do. Would that put New Glenn in the Delta family? Yeah, technically, yeah. So how tall is too tall before you start running into dynamic issues and stability issues? The top of the SLS core is equipped with a vehicle stabilization system, Hokie. You might need another one at the top of the New Glenn stage, but I remember visiting KSE and seeing Orion, and they were saying it was going to launch in a couple of years in 2011. Oh, funny you. We've heard all kinds of good stuff about Orion, like how it launched on EFT-1 with basically a copy of the Apollo's CSM's heat shield, and EFT-1 worked great. And then NASA looked at it and said, "Oh, it works great, but it's too hard to make, so we're gonna redesign it." And they redesign it, and then, you know, like a decade later, almost like 8 years later, they launched it on Artemis 1, and it didn't work. It's easier to manufacture, though. Okay, anyway, that's the architecture I was talking about per the other day. Snackless, thank you for doing this. Let's jump into the rest of the news. So our first news here is coming from bps.space. It's coming from our buddy Joe. If you haven't watched the bps.space YouTube channel, it's pretty awesome. This rocket that Joe launched here is called High Stakes. It is a rocket that flies with a piece of meat as the payload. The aim is to cook the meat on ascent. So here's some footage from that. Headphone users, this might get loud. Headphone users. Headphone users. Okay, it's actually not too bad. Starship upper stage is too heavy, John. Would making a new 8.4 meter diameter stage derived from GS2 really be that much more difficult? No, not really, Bill. The propulsion is your Achilles heel. Yeah, Joe has the roller on. If you look at the fin right there. Hello. Actually, actually really good, man. Like, actually quite good. Parachute pop right at like 2 meters a second. That's real good. That's okay. What you saw, like, I get it. The rocket goes up. This guy Joe, like, once again, BPS is a high-powered rocketry YouTube channel. BPS.space, right? And I'm not going to show the whole video. I'm not going to show you the whole video, but you definitely want to go check this out if you like rockets. Why am I not subbed on the EJ main account? Well, now we are. Joe builds all kinds of model rockets. It's good stuff. Dude, he built, like, he talks about control systems, etc., etc. And you always get great pictures of this stuff because Joe is, he's a cinematographer by trade. So you get awesome camera angles and awesome explanations of things. Yeah. Joe built this in his garage, which is pretty damn impressive. Yeah, that's pretty good. And he's got telemetry and everything. Dude, 848 meters a second. That's okay. I just want to put that out there. With the right conditions and the right temperatures, that's well above Mach 1. Or Mach 2, actually. That's quite fast. Yeah. So, you guys, if you haven't seen BPS.space, go check that out. This rocket had meat as its payload. Flight stats. 33G max acceleration, Mach 2.6. Yeah, see? 8.5 kilometer apogee. Meat internal temperature reached 105 C, 221 F. It's a little on the medium side. He built it in his garage with a pile of scrap. But yeah, if you guys want to see it, the rocket is called High Stakes. Yeah, there we go. See, High Stakes. That's Joe with the chef's hat. Because meat. I think he actually said what kind of meat. Bro, that's an expensive payload. Ah, see, he late loaded the payload for optimum. You know, you got to late load the payload. Good temperature if you're going for braised. Yeah, they ate it too. Oh, that's even better. High stakes. Get it? Oh, high stakes. Whatever happens, we're eating it. Seriously, go check out BPS. Joe's good people. That's an awesome channel. Really, really funny stuff. Like launching meat to Mach 2. You know. It's fine. Don't let the birds get it. Did he launch a Tesla Hot Wheel? I don't remember. Maybe. I've been following Joe since 2015, I think. Anyway, his collab with Zyla was great. Yeah, they launched a Christmas tree into... Yeah, not into space, but maybe soon. Anyway, next bit of news. This is coming from PLD Space. A toda máquina con la fabricación de las estructuras de Miura 5. Nuestra planta productiva no descansa con la fabricación de las estructuras que componen el cuerpo de nuestro cohete Miura 5. They've finished the fabrication for the structures for their new Miura 5 rocket, just in case anybody is wondering. See? You read that well. Gracias. Click the translate button. All right, fine. Full steam ahead with manufacturing the Miura 5 structures. Our production plant does not rest with the manufacturer structures that make up the body of our Miura 5 rocket. The material we use in the main structure Aluminum 2014 is machine curved and welded with the latest technology by our qualified team of experts, following the same practices and principles that were previously validated with Mura 1. So PLD is a Spanish private aerospace company that's working with their Mura rockets to provide payload services. It's all commercial, which is pretty cool. Aerospace is growing everywhere, which is fantastic. Yeah. 2014 aluminum ISO grids. See the triangles? ISO grids, not ortho grids. Pretty good stuff, man. Oh, yeah. Oh, dude, look at the billet. The billet, though. Oh, yeah. Ask Alex to translate. That's pretty sick, dude. Vamos, Mura 5. Let's go, Mura 5. All right. Sweet. We'll soon be showing off the material on the qualification campaigns. Excellent, excellent, excellent. That does not look like it's reusable. Okay. Anyway, next bit coming from Astrobotic here. 2024 wasn't just about roasting turkey at our propulsion and test facility in Mojave. If you know, you know. I was on vacation when they shared that. They put a turkey behind a rocket engine and fired it to cook the turkey. That did not end as good as you might think. Anyway, earlier this year, we opened our Lunar Surface Proving Ground, a 100 meter by 100 meter high-fidelity 3D testing field which mimics the topography and optical properties of the moon's surface. Word. LSPG debuted as a test site for several winning teams of NASA's Flight Opportunities and K-12 Future Engineers TechRise Student Challenge. 30 winning teams of 6th through 12th grade students flew their experiments aboard our Zodiac rocket lander over the LSPG. This summer, teams from NASA's Tech Leap Prize Nighttime Precision Landing Challenge tested their tech at LSPG, which is the most realistic testing field of its scale, modeled directly from a lunar surface map anywhere in the world. Cool. Yeah, little VTOL lander. Show us the turkey. All right, all right, all right. So see the turkey right there? Yeah, see? See, there's no turkey there anymore. Yeah. Funny you, I'm currently working on a nanosat launch vehicle here in Brazil. We haven't talked a lot of PR yet, but I can hook you up if you want. We'll see. See, there was a turkey here. And yeah, see, that now there isn't. Burb. Oh, also, the jet just decided to eat that angle iron right there. Like, yep, no, it can't be stuck if it's liquid. That turkey should have gotten a pardon. Yeah, see, that one wasn't pardoned. Yeah. There doesn't seem to be much left. Also, that box steel right there is not box steel anymore. They did him foul. Ay, diablo de Mari. Oh. Oh god, branches are falling on the roof of my garage. They really zip tied it. Let's be real, drummer. They could buckle that down as many ways as they want. That turkey ain't surviving being behind a rocket engine. Not much survives being behind a rocket engine. Should have used Gorilla Tape. Oh yeah, actually no, scratch that. That may have worked. That may have worked. But anyway, yeah, that's what Astrobotic's up to. Let's keep going with the news. Okay, check this out. NASA has their first accident investigation report from another planet for the Ingenuity helicopter. They did helicopter on Mars. Read more about the details presented at AGU 2024 and learn how Ingenuity still contributes to exploration despite being permanently grounded. We did that with a pumpkin on Halloween. All right. NASA performs first aircraft accident investigation on another world. The review takes a close look at the final flight of the agency's Ingenuity Mars helicopter, which was the first aircraft to fly on another world. It's Box Steelint, that's right. Engineers from JPL in Southern California and AeroVironment are completing a detailed assessment of the Ingenuity Mars helicopter's final flight on January 18th, 2024, which will be published in the next few weeks. Did you guys hear that? I'm like, don't kill me. Jeez. It's a little windy outside. Designed as a technology demonstrator to perform up to 5 experimental test flights over 30 days, Ingenuity was the first aircraft on another world. It operated for almost 3 years. It operated for 3 years? Remember that. I do. But performed 72 flights and flew more than 30 times further than it was planned while accumulating over 2 hours of flight time. The investigation concludes that the inability of Ingenuity's navigation systems to provide accurate data during the flight likely caused a chain of events that ended the mission. The report's findings are expected to benefit future Mars helicopters as well as other aircraft destined to operate on other worlds. Okay. Flight 72 was planned as a brief vertical hop to assess Ingenuity's flight systems and photograph the area. Data from the flight shows Ingenuity climbing to 40 feet, hovering and capturing some images. Precipitation may be occurring in your area. Yeah. Yeah. Oh boy. There's more coming. That's great. Bird wanted to be a part of our engineering bay. Oh, Burb. Nice, dude. It initiated its descent at 19 seconds, and by 32 seconds, the helicopter was back on the surface and halted communications. Following day, mission re-established communications, and images that came down 6 days after the flight revealed Ingenuity had sustained severe damage to its rotor blades. What happened? When running an accident investigation from 100 million miles away, you don't have any black boxes or eyewitnesses, said Ingenuity's first pilot, Havard Grip of JPL. While multiple scenarios are viable with the available data, we have one we believe is most likely. Lack of surface texture gave the navigation system too little information to work with. What do you mean, Shaz? The helicopter's vision navigation system was designed to track visual features on the surface using a downward-looking camera over well-textured, pebbly but flat terrain. The limited tracking capability was more than sufficient for carrying out Ingenuity's first 5 flights. But by flight 72, the helicopter was in a region of the Jezero crater filled with steep, relatively featureless sand ripples. Okay. I'm sorry, what is that? That's not Ingenuity. Mars chopper. Okay. One of the navigation system's main requirements was to provide velocity estimates that would enable the helicopter to land within a small envelope of vertical and horizontal velocities. Data sent down during Flight 72 shows that around 20 seconds after takeoff, the navigation system couldn't find enough surface features to track. Photographs taken after the flight indicate the navigation errors created high horizontal velocities at touchdown. In the most likely scenario, the hard impact on the sand ripple slope caused Ingenuity to pitch and roll. The rapid attitude change resulted in loads on the fast rotating rotor blades that were well beyond their designed limits, snapping all 4 of them off at their weakest point, about a third of the way from the tip. The damaged blades caused excessive vibration in the rotor system, ripping the remainder of one blade from its root and generating an excessive power demand that resulted in loss of communications. RIP. Yeah, she just came down a little bit too hard. Yeah, and then doing this will basically cause all kinds of gyroscopic forces on the blades. Yeah. Yeah, bad. Yep. Rotor imbalance leads to blade ejection. And brown. Yep, okay. Down but not out. Although Flight 72 permanently grounded Ingenuity, the helicopter still beams weather and avionics test data to the Perseverance rover about once a week. The thing's still alive. That's awesome. The weather information could benefit future explorers of the Red Planet. The avionics data is already providing useful to engineers working on future designs of aircraft and other vehicles for the Red Planet. Cool. Because Ingenuity was designed to be affordable while demanding huge amounts of computer power, we began the first mission to fly commercial off-the-shelf cell phone processors in deep space, said Teddy Xanatos, Ingenuity's project manager. We're now approaching 4 years of continuous operations, suggesting that not everything needs to be bigger, heavier, and rad-hardened to work in the harsh Martian environment. That thing's running off a cell phone processor? Which one? Really? Huh. Inspired by Ingenuity's longevity, probably an A8, NASA engineers have been testing smaller, lighter avionics that could be used in vehicle designs for Mars sample return. Okay. The data is also helping engineers as they research what a future Mars helicopter could look like and do. Nokia. Yeah, there you go. Interesting. During a Wednesday, December 11th briefing at the American Geophysical Union's annual meeting in Washington, Xanatos shared details on the Mars Chopper's rotorcraft, a concept that he and other Ingenuity alumni are researching. As designed, Chopper is approximately 20 times heavier than Ingenuity, could fly several pounds of science equipment, and autonomously explore remote Martian landscapes while traveling up to 2 miles in a day. Ingenuity's longest flight was 2,300 feet or 700 meters. Ingenuity has given us the confidence and data to envision the future of flight at Mars. More about Ingenuity. Yeah, we know about that. That's awesome, dude. Super cool. Considering that Ingenuity was like a last-minute thing added to Perseverance, that's pretty sick, dude. This was like something that they threw together in like 5 months. Qualcomm Snapdragon 801. Oh, the derail VOD got claimed. By the way, it got claimed by music that definitely didn't play in that VOD. That's good. That processor was announced in 2013, so a Qualcomm 8, what is it, an 801? A Snapdragon processor. Let's take a look. It's a smartphone CPU. We know, Rafal.